Welcome back to V11PH1-2206. Our earlier video was numbered V11PH1-2206 Part 1. Today we are going to conclude the same video in terms of Part 2. That is, today's video number will be V11PH1-2206 Part 2. And the topic is, as you all know, just how we can try to enhance our score in physics exam by improving certain methodology of answering the questions. That's all. Let us start. In the first part of our video, V11PH1 Part 1, we have covered up to point number 3, and today we shall take up and start again from point number 4 and conclude the entire video in part number 2, that is V11PH1 Part 2. Thank you. We shall now come to point number 4, which states units and definitions provide dimensions, that is the fundamental dimension in terms of MLT first, and then state the SI or CGS units. In answers asking definition of a physical quantity when 2.5 marks and above is allotted, mention the fundamental dimension and whether it's a scalar or a vector quantity, besides the definition and algebraic expression. You must do this thing. State the nature of the curve 2, for example acceleration. State that it is a vector, then state that its dimension is Lt to the power minus 2 because its velocity minus velocity divided by time, that is Lt to the power minus 1 minus Lt to the power minus 1 upon t, which gives Lt to the power minus 2, and then state that for linear uniform acceleration the velocity versus time curvature is a straight line of constant slope or gradient, and that this gradient presents the acceleration value. Then state, after doing all these things in terms of fundamental dimension, then state the units centimeter per second square and meter per second square in CGS and SI system. If a parameter is a pure number, that is, it is dimensionless or unitless, state why it is so. For example, strain. It is a ratio of two similar quantities. In statements of laws, never omit the conditional constraints. What are conditional constraints? Do not omit phrases like for a given mass of a gas or pressure remaining constant. If you forget to write these things, the whole thing becomes meaningless. These are called the conditional constraints. So, these must be very carefully adhered to. We now come to point number 5, that is regarding numerical problems. First of all, while working out a numerical problem, on the left top side, list down the given data and write a concluding sentence after you have computed the parameter to be calculated. After you have done that, write a concluding sentence. So this is this. For example, say, so the stress at this value is so many newtons per meter square. Like that. However, it's most likely that you will use some algebraic equation or expression for calculating a parameter. No equation should be used before stating theoretically the algebraic form for once. For example, to calculate, say, coefficient of linear expansion from given data, first you have to write, we know that alpha equals to Lt minus L0 upon L0 into T2 minus T1. Then you can go for computation. And other than that, stepwise in every numerical problem from whatever chapter it is, when you go on calculating parameter after parameter, at every step write down every parameter with the proper unit. Just don't leave it as a number. Now we shall come to point number 6. Actually, this one relates to short or medium sized questions and answers. Always try to hit the fundamental point in the first sentence. Then, if necessary, elaborate adequately according to the marks allotted. And whenever possible, graphs are desirable. Then let us explain the meaning. If a medium or short question like explain induction precedes attraction in magnetism, or why ice floats on water in heat, carrying say 2.5 marks is attempted, try to hit the basic and fundamental root cause in the very first sentence. Then you may put a subsequent paragraph to elaborate on the point if marks distribution demands so. But be very brief and mathematical in approach. Say, as an example, regarding why ice floats on water. Any given mass of water undergoes volumetric dilation on solidification. So water converted to ice has lower density than the water itself. This should be your first sentence to hit as the root cause. Then writing 11 cc of water on solidification becomes 12 cc of ice, etc. is subject to other considerations such as how much marks is allotted, how much time is left, like that. In such questions and answers, very elementary depiction of relative variation of two properties by a graphical figure is very well appreciated. For example, in gas laws, you are discussing isothermal expansion of gases. Then V varies as 1 by P is Boyle's law, and the nature of variation between volume and pressure is hyperbolic. So you can simply show by a hand-drawn diagram the hyperbolic variation between P and V. So such graphs, although not drawn to scale or to any specific data, will help you enhance the amount of marks you obtain. We have now come to the end of today's discussion. Number 7 is diagrams. Now this is basically based on common sense. So diagrams are a must for deduction based answers. As it is, you cannot do any deduction unless you refer to some diagram. So diagrams must be drawn in deduction based answers. Now diagram size. Supposing, say, this is one half of the paper, this is another half of the paper, folded in between. Now, if you start answering such a question based on deduction over here, about the middle of the second page, your diagram will take this much of space and the actual body of the deduction will go to the next page. So every time the teacher or whoever corrects the paper, he wants to refer back to the diagram, he will have to turn over the page, and this becomes an extremely irritating thing. So always avoid doing this thing. Your diagram should be normally in an answer which is based on deductions. Your diagram should be drawn, or such a question should be started, say here. The diagram is here. This is the space left for your body of the deduction. This whole page is left for your body of the deduction. So the teacher, whoever corrects the paper, doesn't have to turn any page over. And for you too also, if you have to turn the page, you look back at the diagram, then turn the page again and write it. Here you are most likely to commit a mistake. So avoid that thing.